So again, just reading it for the recording's sake. A self-serve frozen yogurt store sells servings up to 12 ounces. It charges 50 cents per ounce for a serving between 0 and 8 ounces and $4 for any serving greater than 8 ounces up to 12 ounces. So raise your hand if you thought the situation was best represented by A. Okay. Raise your hand if you thought it was best represented by B. Raise your hand if you thought it was best represented by C. And lastly, raise your hand if you thought it was best represented by D. Okay, so good job, guys. B is correct. And why is B correct? Josiah?
And then they keep going up until they don't do, and then the flat line is individual, which is that support out.
Okay, so to summarize, what he said was great. It's a constant rate up until it's 8 ounces, right? So we should expect when it's a constant rate to be linear, right? 50 cents per ounce. And then once it hits 8 ounces though, it's just one price. And then up to 12 ounces, which is where all of our x-axis ends anyway. So when it's the same price for a certain amount, then we can expect it to be flat, right? So this one, that's represented. Now let's briefly talk about the goal for today. So I mentioned this is our last lesson of the semester. That's really exciting. We are gonna look at functions that are defined in pieces. So the lesson is called Piecewise functions. By the end of it, you need to be able to make sense of a graph of a piecewise function in terms of the situation, sketch it when rules are given, make sense of the rules of a piecewise function when they're written in function notation and explain what they mean, and understand what makes a function a piecewise function. All of those skills are on your practice constructive response test. I'm not formally passed this out. It's been available though in Schoology if you wanted to do it on your own paper or send in the bin if you wanted to grab it. But very first question is a piecewise function. Very last question, piecewise function. So this is really mostly tested on your constructive response. Okay, so just keep that in mind. I'll give you the paper officially tomorrow, but you're welcome to grab it today if you want to get ahead. So I'm recording right now, but most of these lessons I did last year, so if you ever want to get ahead, they're usually in there. Puzzle piece is lesson 12. Binder check is this coming Monday for unit 4, and Mondays are shorter days, so we're hoping to get those like really quick so that I can answer any of your last minute questions about unit 4 because we test for it Monday. All right, so binder check Monday. You should have tomorrow to work on your study guide, so hopefully you could get, a lot of your questions answered already. But definitely take the weekend, come prepared Monday with your questions. And you could always email me, I do respond, if you check my email constantly. So if you have a question math related, usually I'll respond with either an explanation, a video, something helpful. So there's really no excuse. You gotta ask those questions or else it's still gonna be something you're questioning on the test. These are all available for studying, all at the top of your Schoology. So every unit test, you've had a 100-point study guide that matches the 100-point portion of your test. You've had a constructed response portion for 50 points. And then you've had an extra credit one. And depending on how you score on it, you can get up to 100 extra credit points on that. So if you're behind and you're having to pick and choose what to do, I would make sure my binder's ready first, that I understand all the lessons. And then I would do these study guides before I go back and try to do those 10-point homeworks. Okay, these are worth way more points. They're closely aligned to the test. We literally, when we made them, looked at the test question, changed the number, change the picture. That's really it. So highly recommend those. Tomorrow you'll have a short quiz, probably in the last 25 minutes of class. So tomorrow you'll work on your study guides. And then quiz. And then all the assessments for the rest of the semester are there. So questions on anything I read? Alrighty then. Back to the lesson. So first activity. And maybe we should also define piecewise functions. So let me actually pull that up. That's why I left a little bit of extra room right after, under where it says postage stamps on your paper. It says the relationship between the postage rate and the weight of a letter can be defined by a piecewise function. And then I bolded it, left a little bit of extra room so that you could write down the definition, which is here. All right. A piecewise function is a function defined using different expressions for different intervals in its domain. So for me, I do piecewise function, little arrow, write that, what I underlined. So it's definitely a function. That means for every input, there should only be one output. And we use different expressions for different intervals in the domain. And you'll see when we do the first example. Okay. So is it a piecewise function? Yes, if they use different expressions for different intervals in its domain. So when you look back to the one about the frozen yogurt, from 0 ounces up to 8 ounces, it was 50 cents per ounce. And then from 8 ounces to 12 ounces, it was $4. So like the different expressions would be for the bell work, 0.50x when x is between 0 and 8, but not necessarily including the 8. Once it hits x greater or equal to 8, then it's just $4. So these would be your different expressions. These would be your different intervals in the domain. Yesterday we learned what domain is. Domain refers to all the what in a function? X's. So when we're talking about different intervals for the inputs, defining them differently, then that's a piecewise function. Okay, going back to the activity though that we were talking. So, and these definitions will be in the notes, so no fear if you're a little slow on taking notes, we just gotta keep them moving. So. Back to the example. The graph shows the 2018 postage rates for using regular service to mail a letter. What is the price of a letter that has the following weight? And then answer, a letter costs 92 cents to mail. How much does the letter weigh? So I'm gonna have you start with these two, just try them out. And then we'll see if you're right. Just based off those two before we move on. Give you another 2 minutes. Table 5, what is the price of a letter that has 1 ounce? Sorry, one more time. 50 cents. Do you guys agree? Okay, so this would be an input, and I know that because it's on my x-axis as a label. If my input is 1, see where the 1 touches on the graph. Technically, there's 2 things there, but we saw in a Kahoot, if we have an open circle and a closed circle, which one do we go with? The closed circle. All right, if it's open, that means that's not part of the solution. So then when you read it, what the output is there, yes, 50 cents, then it's 1 ounce. All right, good. Table 6, what about when it's 1.1 ounce? 75 cents. Is correct. So as soon as it stops being 1 ounce, even if it's a little bit above, it now moves up to this price range. And then table 7, when it's 0.9 ounce, how much does it weigh? 50 cents. All right, that would be right before the 1 on this solid line. All right, so questions on figuring that out. That'll be on your constructed response and on your illuminate part. So if you could just read it, great. You've already got a few secured on your test. Table 80, you'll answer the next one. A letter costs 92 cents to mail. How much did the letter weigh?
Yeah.
Okay, 3 ounces. So let's see. 92 cents must be this line. Could it be another weight? Class. So really above 2, because once if it is 2, it's 75 cents. So we could describe that in words, we could describe it with symbols, but definitely above 2 ounces up to 3 ounces. You could have said anything there, including the 3, but not the 2. Okay. Now the next part, we're going to compare, because usually with the piecewise functions, you're not just given a graph, you're given a set of rules that look like this, that define each part of your domain. But we have Kieran and May wrote some rules to represent the postage function, but each of them made some errors. So we're telling you that. Each of them made errors. You are going to identify the error in each person's work and write a corrected set of rules. To do that now, I'll give you 3 minutes. Find their errors and then make a corrected set of rules. Can you share with me the error that Kieran made? What's wrong with how Kieran wrote his rule? So you're right. Okay, anyone else at table 1? We'll come back to you, table 1. You guys have Kieran. So keep looking at it, keep trying to figure it out. Table 2, what about May?
Right after the W are all
So the fix would be to make them all with a little line underneath.
Yeah.
Okay, so let's see if that change fixes it. So for May, if it's this type of symbol, should I expect an open circle or a closed circle? Open. Okay, so if you want to remind yourself the inequality rules, it's similar like when we graphed those for this and for this, we used open circles. So if May's using an open circle next to the 0 or on the 0, so I suppose that should be open. And then the fix would be to make this to where it would be for your closed circles. So yeah, the little line underneath does make that a closed circle instead. So yeah, let's see if that's the only error. So from 0 to 1, including 1, it is 50 cents. From 1 to 2, including the 2, it is 71 cents. That looks pretty good. From 2 up to 3, including 3, is 92 cents. And 3 up to 3.5, including 3.5, is $1.13. So we might have to adjust our answers up here. We estimated it a little bit differently, but according to their rules, that looks more accurate. The only change needs to be that the line is added on the right side. So then table one, what's wrong with appearance? Okay, good. Fix all of these to where they are less than. And then would that be the only change we need to make? Okay. And that would be for all of them. On this side. There are no open circles on the left side of each line of each piece. So they would all have to change to that. And also see that they're opening the right way. All right, when we put X in the middle of numbers like that, we're basically saying it can be between. And then you have to show what it's including and what it's not. So then to rewrite that, it would be really similar, just now with the correct symbols. All right, so questions on that? Do you think that you could read it on the test? I feel like usually more so you'll be given a weight and asked to say what the cost should be for this example. So like if they said that the weight is 2.3, how much would it cost? Now you guys are writing and maybe not listening at the same time. Give me 1 second. All right, but with this set of rules, that should define what your answers are no matter what the weight is. So what if I said a weight of 2.3? What's my cost gonna be? 92 cents. What if I said the weight was 1.9? What's the cost gonna be? So I should hear more than just Nathaniel. Okay, so then Nathaniel slow down a little bit. All right. If the weight is 2, what's my cost gonna be? 71 if we go with their estimates, but yes. Last one, try to make it a good one. If the weight is 3.4, what's my cost? $1.13. Okay, so really you just gotta see if they're replacing the W, look at where the W's are. See which one it falls in between, and then that's your output. Okay? Questions on that? All right, let's flip to the back and then my notes next. Okay, so now you're going to practice making a piecewise function with the activity on the back when you're given a set of rules. So great practice for your constructed response test. All right, then go on to the next page. Then you take a picture or something, do that now. Gotta get more into taking notes as we go. Okay, so start reading to yourself for bike sharing. Function C represents the dollar cost of renting a bike from a bike sharing service for T minutes. Here are the rules describing the function. Complete the table with the costs for the given lengths of the rental, and then sketch the graph of the function for all values of T that are at least 0 minutes and at most 240 minutes. So let's just start with number 1. Okay. Just like how we did in the last exercise, for each input, determine what the output would be, and then make your graph. Maybe like, I don't know, 3 minutes to do that. So first you got to complete the table based on the rules. So let's see, table 2, when it's 0 minutes of writing, how much does it cost? $0. All right, class, agree? That's probably the only thing that makes sense, right? Why would they charge you if you're not writing it at all? But also if you look at the rules, remember the T is my input. So look where the T's are. This doesn't say including 0, right? There's no little line underneath. So it's not 250 for that one. I know sometimes it's questionable whether or not you include the 0 on your graph. I say include it. I've seen it more times than not on your test where the 0 is included. So good. Then table 3, when you ride the bike for T minutes, how much does it cost? 2.5. So $2.50. Table 3, when you ride the bike for 25 minutes, how much does it cost? $5. Class, we agree? So fine, 250 is correct. Fine, where T could be 25, is 25 between 0 and 30? So then you look at that output. And that tells you. So then table 5, what about when it's 60 minutes of riding? Okay, 750, class, agree? All right, so notice there's 60 written twice for our interval rules. Only one of them includes the 60 in the interval. Which one? The one with that, well, it's really less than or equal to, but yes. The one with the little line underneath, right here. So that would include the 60 in that interval, which makes that price $5. Because you can't have two different prices for the same amount of time, right? So it's just one, that's why they define it that way. We gotta show where it stops at. So for 60 minutes, $5. Table 6, what about 75 minutes? 750. And table 7, when it's 130 minutes. 1250 is correct. And then table 8, when it's 180 minutes. $50. All right, so I think the function notation helps, especially if they say T minutes, right? Gotta see where 180 fits between the 150 and 720, $15. All right, now to make the graph, usually when we have a table, we make sure all those points are on there. But since this is a piecewise function, you mostly have to go based off the rules that you're given. Okay, so remember, T's are my inputs. That's what's on my x-axis. So when T is 0, what's my, well, technically my output 0. So maybe let me start with the different one. Let me start with the end of it. When T is 30, what's my output? So then I need to make sure I have a closed circle there. And then everything above the 0, not including the 0, is included in the answer. So even if it was like 0.01 of a minute, that's included. So the way that I represent that would be an open circle where it's 0 and my output is 250. And then since it can be everything in between, we're going to put a solid line in between. And that's my first interval. My next interval starts at the 30, but it doesn't include the 30. Okay, but what's the output for the next interval? 5. So I need to go to 30 up to 5. Will that be an open or a closed circle? And then I need a closed circle where 60. That's where that price range ends, and then connect them with a solid line. It's going to be that same price. So that's why when we connect it, it's going to be flat, not increasing, not decreasing. Do you think you guys could take it from there? Okay. I did ask you to already try it earlier, but if you haven't yet, try it with the next 4 intervals. I'll freeze it and then I'll show you what it should look like. If you're already done, try answering 2 and 3. Describe in words and determine the domain and range. Great practice for your constructed response. All right, so compare your graph to mine. That's what it looks like. Would this graph still pass the vertical line test? Yes, because even when I draw a vertical line, say like through here, and I can't draw a straight line right now, but through where the input is 120, that open circle still lets this be a function, because you only got one closed circle. If you have 2 closed circles overlapping, like a closed circle here, closed circle here, then it's not a function. So you probably made a mistake because these are called piecewise functions. All right, but yeah, questions on that. And then the graph cuts off at 240. So that's why there's no like closed circle here. Technically, it still goes up to 720 on the interval. So that's why we just kind of ended there. All right, to describe in words, honestly, you have to go interval by interval. So when you see that on your constructed response, please write a complete sentence for each interval. You say from 0 up to 30 minutes, it costs $2.50. Over 30 minutes up to 60 minutes, it costs $5. All right, make sure you're using the correct like phrasing. You would have to mention anything with not a little equal to symbol. You have to mention above. And then with the line underneath, you could say up to or including, but something like that. You have to specify above 150 minutes, up to 720 minutes, it's $15, things like that. Questions on that? So then for the domain and range, what is my domain? What are all my possible x's in this? What's my lowest x value that I can have? And what's my highest x value that I can have? Where'd you get 180 from? 720. Okay. Anyway, oh, because you were looking at the table. Gotcha. All right. If you look at the rules, that'll define basically your lowest and your highest. Or if you were given a graph, my lowest technically could be 0 still. And then my highest could be wherever it ends at. But based on the rules, my highest x could be 720. Could it be everything in between 0 to 720? Are there any gaps at all? Are there anything that's not included? Could I have decimals of a minute? So then when I'm representing this, I can use my inequality symbols. Maybe use that since they didn't have it here with the little line underneath. But then with the other one, the higher boundary, have the little line underneath. That's good for the domain. Or you could say in words, all non-negative, if you can't have negative times, all non-negative real numbers. You might see that verbiage on your test. So real numbers implies it can be a decimal, non-negative, it can't be a negative. All right, now the range. Range refers to all the what in a function? All the y's. So C, what's my smallest y value? So I'm gonna go with 0 because that's like how the test kind of does it. I know it doesn't really make sense if you're renting a bike, like it costing $0, but they include it. So just, you include it too. And then what's my highest y value that I can have? 15. So these are their prices. And is it everything in between? So could they charge, say, $1, $2?
No.
In this case, no. So I'm not gonna represent it as an inequality because it's not everything in between. I'm gonna represent it as a list. So when you're doing it as a list, that means it's only a few options. So it would be 0, $2.50, $5 up until you get all the way to their maximum price of 50. So if I look back to the rules with my next possible Y value, $7.50, my next possible one, my next possible one, and then my last possible one. So my Y's in this situation are really nothing other than those numbers. So I couldn't use an inequality this time because it's not every single number between 0 and 15. It's just those numbers and nothing else. Does that make sense? Okay. And that's pretty much it. There's one more that could be kind of like a cool down, and I'll project the answer and go over it. But if you'd rather start your practice or your study guide, I understand. But this last one that's on your paper, I do think is good practice for your test. And it gives you a piecewise function rule, asks you a few answers, gives you a graph and asks you if that graph is correct. So I will still project those answers and like briefly talk about it, maybe in about, I don't know, 9 minutes, I'll do that. So feel free to try it or start working on your practice if you'd rather do. I did say I'm not like forcing you to do the problem that's on your notes, but I said I'd project it because it is good practice. So here would be the solutions to it. So when you look at functions like C, you might be asked, why is it a piecewise function? You could use the definition I told you earlier, or you can put it in your own words, but basically there are different expressions for different parts of the domain. Okay, so there you go. And then be able to answer no matter what the input is, what's the output? So C, 0.5. 0.5 shows up in 2 places, but it can only be one price. How do you know if it's that price over the other? A closed circle, or if I'm looking at the rules, what would I look for? The equal to part of the inequality, right? If that little line is not there under the inequality sign, then it's not included in that interval. Okay, it's only here. That means when A is, or it's A of 0.5, my answer is correct. Same with the 2. The 2 shows up twice, but only one of them says when it's equal to 2, and it's this one. So in that case, that output is 10. I gotta flip to the next page. But the next page said, here's an incomplete graph of function C. As is, why is it not a graph of a function? So think, what makes something a function or not? I said for some of the x's, like 0.5, 1, and 2, there is more than one output. All right, we know that for functions, for every input, there's just one output. So the way that it looks right now would not be a function. It says, how can we fix the graph so that it does represent C? I described it in words. I even drew on it at first. Basically, if I put an open circle on the left part and the closed circle on the right part of each segment, then it's now a function because then there's only one output. For the very last one, because my interval actually ends at 8, not 6, I won't put a closed circle there. I'll just leave that part alone. Okay. Then domain and range. All right, it does touch everything after 0 through the 8. So you should use an inequality for that. For the range, it's only a few numbers. So for the range, I just list what those numbers could be. And I included 0 because on the test, it includes 0. Obviously, if the input 0, the output is 0. But that's just, I'm going based off the test on that one. So good, any questions? Okay. So then study guides. Feel free to look them over tonight. Come prepared with questions tomorrow.